Hello and welcome to this new ER2 Modding SDK tutorial. Today we're gonna take a look to vehicle with tracks, so mostly tanks and similar vehicles. Vehicle with tracks are very similar to vehicle with wheels, but they have a difference, which is of course the tracks. So let's import a tank model and let's take a look on how these tracks works. So the model I'm gonna use is a model you will be able to find in the examples folder of the ER2 Modding SDK. And it's the sample tank model. Since we are importing an FBX, remember to set ignore leaf bones. Let's start by focusing on what are the main differences from a vehicle with tracks from a vehicle with wheels. And the main difference is of course the tracks. So we can hide the hull, which is gonna be working just like any normal vehicle. Let's hide the turret, which is gonna work just like a normal turret. And let's hide the wheels, which are gonna work just like almost normal wheels. We're gonna take a look at them later on in Unity. So let's see how the tracks works. So there are two main things we want to see on tracks like this. First is the effect where the tracks looks like they are rolling on the terrain. And second, the deformation of the tracks where it run over an obstacle. Virtually, you could reuse these tanks tracks models for your tracks vehicle models. So let's go to the UV editing section and let's enable the textures. Notice how the texture of these tracks is seamless over the y-axis. The reason for that is because our tank tracks are UV mapped on top of that. This means that if we take this tank tracks UV map and we move it along the y-axis, our tracks will have an effect which looks like our tracks rolling on the ground. And this is exactly what the game will do when it will want to give you the effect of the tracks moving. It will move the UV map up and down in the y-axis. Notice also how the two tank tracks should be separate model, so their UV map can move independently one from the other. Let's now go back to the modeling view. So now we want to have this rig being able to deform on the ground. So basically I prepared a rig here where I can move the bones and deform the base of the tracks over obstacles that they encounter on the ground. I won't really explain how to do this right now on Blender because that's a bit of a complex thing. You will need to follow some rigging tutorials. However, I can show you very quickly how this rig, which has some issues as you can see because this is just an example rig, but how this rig is achieved. So if we select the mesh of one of these tracks and we go in wave paint, you can see how each of these bone is wave painted on a section of the tracks where it can touch the terrain. Basically, in game, we will have some virtual wheels, one for each of these bones, that will be able to move up and down the bone when the wheel touches an obstacle. So this is the main difference between a normal wheeled vehicle to a vehicle with tracks. As the vehicle with tracks will have this tracks component we just discussed. However, if we enable the rest of the parts of this tank, we can quickly take a look on everything else that we are gonna set up later in Unity. So first, we have the hull, which is just a normal mesh for it. Then we got the turret that can rotate over its z-axis, and this is the y-axis in Unity, by the way. Make sure, of course, that your tank is looking at the -y Blender axis. The same as the turret, the barrel can rotate along the x-axis. Notice that these pivot points should be already configured well in Blender, but if they are not aligned correctly, you can still work around that later on in Unity. I still would suggest to fix them directly inside your models though. Last, notice how each of these wheels has its pivot point in the center, and each it's a separate model. We are now ready to export, so let's select everything by A and choose Ctrl A, rotation and scale, to apply this scale and rotation as the default scale and rotation of our model. Now let's go to export, select where we want to export our model, normally inside your project. I will move this in the project manually later on, and choose apply transform and apply scaling to FBX unit scale. Now let's see how to set up this correctly inside Unity. So now that we are in Unity, we imported our model here. We also imported the materials for the vehicle and for its tracks. So as usual, let's right click on the mesh and choose ER2 Mods, Vehicle, Tank Template in this case. First, let's notice how this tank was rigged. So we have first 8 different points that can deform. Notice that the maximum amount of points that can be deformed in a vehicle like this is 8. Normally 6 or 8 is good for a tank, while 2 or 4 is good for an half track. Notice how each wheel here is separate from the other and has its pivot point in the center. And finally, notice how each track here is separate from the hull, and how we can change the Y offset of the material to move the track, or at least to give the impression of the track being moving. So now let's start setting up the wheels. First, notice that you can have a maximum amount of 8 physical wheels. If you have more than 8 wheels, the other wheels will need to be fake wheels. They will basically do a rotation and a position based on a physical wheel that is close to it, but only 8 wheels will be able to have a physical wheel collider. The same limit again is on the tracks that can have maximum of 8 deformation points, so each point can be connected to one physical wheel. So let's see how to actually set this up. First, let's choose which of our wheel will be the actual physical wheel. In this case, I suggest this wheel, these 2 wheels here, and this wheel here. Then I'll do the same on the other side, so these 2 and this one. So basically we will have wheel collider on these 8 wheels. Again, for a tank, 6 or 8 wheels is a good number, while for a vehicle like a half track you can have like physical wheels, while for a car where you have less than 8 wheels, you can just choose to set all of your wheels as physical wheel collider. The problem normally comes when your vehicle has multiple wheels, like the case of this tank. So selecting these 8 wheels, I can now go here and choose ER2 Mods, Vehicle, Wheels, Setup Wheels. And I will have this menu. This can look scary, but let me explain. First, we got an ID for each physical collider wheel we are setting up. So this wheel ID are all the 8 wheels that we selected. So we got this, and so on. The wheels we selected a second ago. For each of these wheels, we are gonna create a wheel collider, and this is the side of the wheel collider that the vehicle will recognize to be. It's already set to be left or right automatically, but you might want to adjust it yourself, especially in case this value gets wrong, but it shouldn't be normally. Then, for each of these wheel collider, we have the submeshes. In this case, we have only one submesh for wheel. Basically, for every collider, you're also gonna assign which mesh is gonna follow that collider. So of course, for each of these collider, also the same exact wheel is also assigned to be a submesh. So while this collider will actually keep track of the collision of the wheel with the terrain, this will update its rotation, steer, and spring value. What are these values? So basically, the rotation means the rotation of the wheel rolling on the ground. The steer means the rotation of the wheel steering left and right. And the spring means the movement of the wheel up and down due to the spring of the damper of the wheel. We can also set the wheel to be only rotation, making it to only follow the rolling on the ground and not the steer, neither the spring. Or we can set this to bone, but we are gonna see this in a second. In this case, we can only set wheels like this to rot, steer, and spring, or only rot. For this wheel, we want this to follow completely the wheel collider, so rot, steer, and spring is good. Also notice how we can make each individual wheel collider being able to steer for a maximum value. In this case, it's 0 for each wheel, because in a tank you can't steer your wheels. But if this was a car, you might want to choose the forward wheels. In this case, the wheel left 2 and the wheel right 2, which are this and this one, to have a steering angle. For example, something like 40 degrees is normally okay. Some vehicles can also have the steering wheel in the back, being able to steer in the opposite direction. For example, the Puma. And if you want the back wheels to steer in the opposite direction, you can set them to be a negative value. So for example, -40. But again, this is a tank and wheels are not supposed to steer, so everything can be set to 0. Also, normally when you are going to set up the wheels with a vehicle which is not a tank with this script, the steer value is already automatically assigned, so you don't have to worry too much about it in case you forget. So we just set up the wheel collider for each of the wheel we selected. So this wheel, this wheel, this wheel, and this wheel for this side, for example. And we also set them to follow the rotation, steer, and spring, and the steer angle of the collider. So these wheels are now correctly set up. But we want also to have this wheel here, this wheel here, this wheel here, and this wheel here to also rotate with the trucks. And also we want the trucks to roll on the ground and deform correctly. So let's move on setting up the rest of the trucks. First, we might want to have this wheel and this wheel to follow the rotation of this wheel. So when this wheel rotates, also this wheel and this wheel can rotate with it. To do so, let's search this wheel on the hierarchy. This wheel is wheel 2 and we are assigning it here. So first, let's add couple submeshes, one for the wheel 1 and one for the wheel 3. So now these 3 wheels will follow the rotation of the collider that is generated from this wheel. So this wheel, and this wheel will follow the rotation of the wheel collider generated on this wheel. Notice how we want this wheel and this wheel to also follow the spring, but we don't want this wheel to do so, because this wheel won't have any spring in this position. So we can set the wheel 1 to be only rot. Finally, we want this part of the track to move up and down with the spring of the wheel collider generating on this wheel. So to do so, we can add another submesh, drag and drop the bone of this track part into our menu and set this to bone. So now when this wheel rolls and moves up and down, or at least when the collider attached to this bone rolls and moves up and down, it will make that this wheel is updated in rotation, steer and spring. This wheel is updated in rotation. This wheel is updated in rotation, spring and steer, and this bone is updated in spring. Now we can do the same for every other wheel we have here. So we set it up these 3 wheels already. We can move to this wheel, which is this wheel here. Notice how this wheel doesn't need to control any wheel around, because this wheel is already controlled by this one, and this one is a standalone wheel. But this wheel needs to control the deformation of this track part. So we can add a submesh and add the bone of this track part and set it up to bone. Moving on, we got the next wheel, which is the same. It's quite standalone, doesn't need to update any of the wheels around, but it needs to update the bone of the tracks. So let's place the bone of the tracks there. Then let's move on to the last of the wheels on this side of the tracks, which is this one. And this again has one wheel to control here, one wheel to control here, and the bone. So let's add 3 submeshes, and then let's assign this wheel here, this wheel here as well, and this is only rotation because this doesn't need to move up and down with the spring. And finally, the bone of the track here to bone only spring. We're gonna do the same on this side. I'm gonna do that fast without explaining much because it's exactly the same. So let's add 3 submesh here, and let's assign this one, the bone, and the last one. Okay, everything should be good now. I don't have much time to double check, but I'm confident the setup is correct for the wheels. The last thing we need to assign here is the mesh of the left track and the mesh of the right track. So our tank script will know which one are the left and right track meshes to be able to move the texture of the track when the tank is rolling on the ground. We can click on finalize, and as you can see, we have this new object here where we got our wheel colliders, all the wheel meshes, and each of our wheel collider has a script assigned to all the components that it needs to control. This for each wheel collider. To finalize this, we might want to adjust our wheel collider. So in this case, this is a little bit too big. We can either move these colliders up and down to make them touch correctly the ground, or we can just decrease the radius. I'm gonna just move this a little bit up in my case, because having big wheel colliders for a vehicle like this is gonna be a little bit better to avoid having the tank getting stuck in obstacles. We can also move some colliders a little bit forward and some others a little bit backward, so they will be at the same distance one from another. So to finalize our tank, let's see what other components we have. For example, we got the box collider on the root component. We can adjust this, and we can also set an armor thickness value. Then we got also this front collider here, which is a little bit different from the one on the root. First, because as you can see, this is rotated to match the angled armor of our tank. And also this has a different armor thickness value. You can do stuff like this all around your tank in case your tank has angled armor or has parts where the armor should have a different armor thickness. You can of course do this also with other kind of vehicles, not just tanks. We got our muffler smoke, set it up also on our script here. This is where you can find the reference to your muffler smokes. We got our internal vehicle parts that can be individually damaged. And we got the sound for our tank tracks rolling on the ground. We can now finalize this tank, adding a turret to it, or at least setting up the turret components. So to set up the turret components, first let's select our turret mesh, in this case sample tank turret. Let's right click and choose ER2 vehicle turret. In this case I want a gun and MG turret because I want this turret to both have a gun and a coaxial MG. So when I select this, a Y-axis is created and our turret can move around that axis. This works fine because our turret had a correct pivot. In case your turret didn't have the correct pivot, you might want to move your Y-axis and your turret mesh to find the best position to have the correct rotation. We want to do the same with the X-axis, which in this case didn't set up correctly because our gun should rotate around this axis, but our X-axis position is here. So we want to move our X-axis to be in the rotation position of our gun. So this is the position circa, and we can move the gun of the tank inside the X-axis. So when the X-axis rotates, also the gun inside it rotates. Inside the X-axis we also have a scope position. So the scope position is the position where the scope is spawned when aiming down sight. In this case is approximately here. So I'm placing this position here. We got the fire gun position, which is the position where our main gun fire, and it's approximately here. We also got the coaxial MG fire position, which is around here. One thing you might want to notice when setting up the Y-axis is that the Y-axis is also gonna create its own collider here, because turret normally will have their own collider. You can either remove these two components from the Y-axis or set up the collider for your turret. The collider of your turret can be composed by only one collider or multiple colliders, just like the base of the vehicle. You can create an empty and add new colliders here in case you want different colliders with different armor thickness, just like the base of the tank. But for this quick test, I'm just gonna make a very simple collider like this. And I'm gonna set its armor thickness to something like 52. So now our turret also, it has its own collider that rotates with our turret. So everything inside our X-axis should be correctly set up. We also might want to add an extra position for a vehicle like this. So we don't only want to have the aiming down sight camera position, but we also want the camera position when not aiming down sight. So when looking normally, we can in the moment set this up. So I'm gonna duplicate with Ctrl+C, Ctrl+V and create a new position. I'll call this cam pose, and this is the camera position just for this turret. I can place it, for example, here on top of this edge. So normally when being in first person and not aiming down sight, I want my camera to be here. And now I can set up my turret script. So notice how the y-axis, the x-axis are already correctly set up. However, I want my y-axis to rotate fully all around in 360, and this means that our bond needs to be 180. This means that our turret can rotate 180 degrees left and 100 degrees right, and since this is the maximum number, it will be able also to do full 360 rotations. This is the gun depression and elevation, which is already quite good in values. As you can see, we got the scope position, but we have the look position not set it up. The look position is the position where we want our camera to be. Normally, if this is not assigned, that is just the position of the head of our soldier, but as our soldier are inside the tank, for a vehicle like this, we want to assign a position. So let's place the camera position here, the one we set it up a second ago. We got the idea of the scope sprite that you can find in the documentation string table, so you can set the tank scope you prefer. This is the rotation speed of our turret. Also make sure that your turret is assigned to the correct seat. So if we go in the seat setup in our vehicle tank script, you can see that here you got all of your seats of your tank, and you can notice how the turret was automatically assigned to the second seat. So the second seat will be the one that will control the turret. We can also want to parent our seat not to the main tank transform, but to our turret. So our seat will rotate when our turret rotates. This won't change much though, because our seat is disabled, so we won't anyway see our soldier inside it, but it's always a good practice to move your seat in the position of the turret when the turret is meant to rotate and the seat is meant to rotate with it. Now we can finalize the setup of our weapons. So our turret has, as said before, two weapons, a main gun and a coaxial MG. So we got the fire position of our gun set it up previously here. So here you can set up various settings for both of your weapons. You got both your gun and your coaxial MG here. So on your gun you got your gun ammo types that you can find in the documentation string table, so you can choose the ammo type you want. You can set the ammo count as well. You can set the fire position of the gun, which is already set up here. You can set the fire sound and the fire sound at distance. You can set if this weapon is recoilless. In this case it's not. This gun is quite a bit of recoil actually. You can set the reload time. You would also have the round per minute, but as this gun has only one bullet per time, this doesn't change much. You can have the dispersion angle, which is the randomized dispersion angle when shooting. And this is everything for setting up the main gun. For the coaxial MG, you see you got the MG42 belt, but again you can set other kind of ammunition from the string table documentation. You can set how many ammunition this has when it spawns. You have the fire position of the MG, the one we set it up before again. You have the sound for firing at distance and close by. You have the round per minute. In this case this is important because this MG has an entire magazine belt of ammo, so this is the round per minute while shooting an entire ammo. You got again the reload time, the dispersion angle, and here you can also specify a tracer ratio for your gun. In this case we want a tracer every 3 bullets. So we set up the turret for our tank, and now we're ready to save our model as a prefab. So let's go into a folder. For example, we can create a prefab folder here. We can drag and drop our tank inside our folder to create our prefab. We can set this to be inside an asset bundle, for example, test tank. And we can now upload our mod. So let's go in our mod menu. Let's choose our test tank bundle. Let's call this For example, let's call this, for example, test tank. As you can see, our tank is inside our bundle. We can set this whatever visibility we want, and we are now ready to start building. Once this process is done, we can subscribe to the mission and check it in game. So now that we are in game, we can either test our tank in the mission editor, creating a custom mission where we spawn our tank, or simply going to the shooting range. So now we can spawn, go to the vehicle selector menu and choose the tank we created. As you can see, I can go inside and move through the seats. If I'm the seat number 1, I can drive the tank. As you can see, the wheels rotate correctly, and also the trucks has this nice rolling animation. So we can also move to the second position and go in the turret. As you can see, in the turret we can stay in the position where we set the camera position to be, or we can just go in third person. We can shoot, switch ammo, shoot with the coaxial machine gun, aim down sight, and we can go to the third position, which is not very useful for this tank. So as you can see, everything is working. Congratulations for setting up your first tank vehicle.